In match problem 1, we're given a function that we want to maximize, which is subject to this given constraint. So step 1 is to simply just state our problem. And that problem is that we want to maximize f of xy equals 25 minus x squared minus y squared, subject to, now we want some function equal to 0. This function that we're given isn't set equal to 0, but if we subtract 4 from both sides, now it is. So our function g of x is x plus y minus 4. So subject to x plus y minus 4 is equal to 0. So this is a critical step. If we left this as x plus y equals 0, our remaining steps wouldn't work out correctly. We need to make sure this second function, all the terms get moved to one side so that this is equal to 0. In step 2, we need to construct that equation, f of x, y, lambda, which is f of xy plus lambda times g of xy. So in this case, that's going to be 25 minus x squared minus y squared plus lambda times x plus y minus 4. And then distributing through the lambda, we get 25 minus x squared minus y squared plus lambda x plus lambda y minus 4 lambda. In step 3 now, we need to find each of those derivatives and then solve that system. So we'll first find the derivative of capital F with respect to x, which will be negative 2x plus lambda, and then set that equal to 0. We find our function f differentiated with respect to y will give us negative 2y plus lambda is equal to 0. And then we take the derivative of that function with respect to lambda, which will give us x plus y minus 4 is equal to 0. So we can take this first equation, solve it for x, to get x equals lambda over 2. We can take the second equation, solve it for y, and in this case we get lambda over 2. So we can take our value for x and y, substitute it in here. So in place of x we have lambda over 2, in place of y we have lambda over 2 minus 4 is equal to 0, which is going to give us a value for lambda equal to 4. So we just add those together and then solve for lambda from there. So we can take this value for lambda, substitute it back in to our expressions for x and y. So this value for lambda is going to mean that our value for x is 4 over 2, which is 2, and our value for y is 4 over 2, which is also just 2. So in step 4, we only came up with one value for lambda, x, and y. So our only critical value is 2, 2, 4. So that's our x value, y value, and lambda value, which means that f of xy is maximized at the point x equals 2, y equals 2. And the maximum value is f of 2, 2, which is going to be equal to 25 minus 4 minus 4, or 17.